guys, Nicole here with another tutorial. Tonight I'm going to be talking about octal numbers, you guys, octal numbers. All right, so yesterday in the last video, we went through how to convert a decimal number over to binary and back to decimal. Today we're going to add octal into the mix. So I hope you guys are excited for this. Let's see how we go today. So let's start with what is an octal number? So first and foremost, what is an octal number? Why do we call it octal number? So it's another numeric system in which each digit, and we talked about digits in the last tutorial, so each digit that makes up the entire octal value can represent the values 0 through 7, which is where the term octal comes from, because octal refers to 8, or base 8. And you'll see base 8 in calculators as well sometimes, a lot of times actually. So Windows calculators, Linux, they usually will look something like this. In fact, I'll bring mine up right now so you can see it. So if I was to bring up a calculator like this, if I just change this to like programming, which I like to use a lot, you'll see there's actually decimal over here. So if I put like 392 in here, this is going to give my answer away. You can see that in decimal, base 10 decimal, 392, like we talked about in the last tutorial, this is that binary number, so we could check ourselves from yesterday. Although we're going to do this manually, so yeah, we're gonna do it the hard way. But you can see that is the number that we got in the last tutorial, and the OCT value that you see there, that's octal, and the top one, 188, is what we call hexadecimal. We're going to go over that in the next tutorial, so more to come on that. Now, so there's a couple different ways you could see it. The Linux calculators will actually show the sub 8 as well. So you'll see it multiple different ways, but I just want to give you an idea. So you can see, and whichever one is highlighted, like you can see in this case, the DEC is highlighted. That's the one that's actually selected, obviously. So I'm going to minimize this here. So the position, just like we talked about with base 10 decimal, the same exact thing. So the position is the location in the, like where something is located on the value, or in the number. And then the value is, just like we did yesterday when we add all the positions up, using the base 8 calculator, that will give us the total number. And there's actually a couple interesting things that we can do. We can do the division method as well. And if you're still a bit squirrely about the binary conversion, don't worry, because we're going to do it again here in a minute. So that is octal. So octal numbers. Now some examples of octal. You might be thinking, like, I know I used to think of this, like, who uses octal? Because in an octal number, each digit is worth 3 bits. And the reason it's worth 3 bits is because, in fact, I'll draw this up here, just like this. So what I'm going to do here is this. So if I was to put, like, let's say 610, I think that's the number that we're actually going to be getting to here in a minute. Let's say that's our octal number. And to write octal, we're going to go like this. We're going to say sub 8, or you could also do 0, little o, and then the number, so 610. Although I don't like this way personally, because the O's can look like zeros. I don't like it. So I usually go with this. But again, you got to be careful, because if you write this like something like this, if you were to do 610 and then like have an 8 like that, that can look like 6,108 as well. So you got, just like we said yesterday, got to be careful. Oops. There we go. All right, get rid of that right there. Okay, so 610. All right, so now I'm going to get rid of this one as well. So let's get rid of that there. So here's our number here. So now why do we have 3 bits? So I'll write this up here so you have it in case you're... So 3 bits, 3 binary bits per digit. Okay, something to remember. Now, why is that, right? So if we just look at these values, so what I'm going to do here is I'm just going to break these up into some sections here. Like this, something like this. And I'm just going to go like that right there. Okay, so now why do we have 3 bits per byte? It was because if we look at this in binary, so if I say least significant bit is over here, go into most significant bit, so you can see, oops, sorry, 4. It is late in the day. 1, 2, 4. So each one has 3 bits associated with each digit. 1, 2, 4. So now think about why this is. So now why is this? Well, 4 plus 2 is 6 plus 1 is 7. So those 3 bits give us the values 0 through 7, which is 8 possible values. You guessed it. So that's where that comes from. So remember, 3 bits per digit with an octal system. Remember that. All right. So we're going to come on this later. So I'm going to get rid of all this here. All right. There we go. All right. So we're back to the drawing board. All right. So now let's go to some examples. Okay. So a couple examples, and there's many out there. One of them is a 4-digit aircraft transponder. So also known as ICAO Mode 3A, or you may have heard it called the squawk code. That is a 4-digit number. 12 total bits make up the entire value. And it's used by like air traffic controllers and stuff to identify aircrafts. So 1200, for example, you might see that. Like it's for VFR, Visual Flight Rules aircraft. And there's some other ones as well. For commercial aircraft, usually the air traffic controller, they're gonna assign, the aircraft. They'll call up the aircraft and say aircraft squawk this value, and usually the pilots will put that in. And in the modern aircraft, usually it's all digital nowadays, but it could be a dial. And I'm going to show you a picture here in a minute. The other thing is Linux permissions. So anybody familiar with Unix or Linux, the permissions are actually, believe it or not, they are also. So let's take a look at this here real quick. So let's look at some examples. So on the left, what we see here is our transponder. So if we look over here, you can see in this case we have 1200. Well, each of these values that you see here, each of those little numbers actually represents. Oops. Let's see if I can get this to work here. There we go. Okay, there we go. We're back. All right. Sorry, technical difficulties, guys. All right. So in this case, this is VFR 1200. So the reason these are each of these little knobs is octals, because if you were to spin this little dial around, this would represent the numbers 0 through 7, each of these little spots in here. So each of these little guys right in here. Oops. Just like that. Oops. The technology today. It's not cooperating today, guys. It's not cooperating. Okay. Perfect. Okay, I think we got it. I think we're good now. I think I made the pen size smaller is what I did there. All right, let's see if I can make that. That's a little bit better, I think. Okay, there we go. All right, so yeah, as I was saying, I couldn't see it before. You can see that each of these little dials here represents the values 0 through 7, which gives us a 12-bit field here total. So 3 bits, 3 bits, 3 bits, 3 bits. So yeah, that's our squawk number that we have over there on the left. You'd see this is a transponder that you'd see in a typical aircraft. And then on the right, this is something that you might see if you're familiar with Linux, and you may have seen this and not realized what you were looking at. But you'll see on the left side over here, these are our permissions. Now, I made a couple of these as tests here, so I don't know if anybody can see this. So what we have here is read, write, execute, just like that. Read, write, execute, read, write, execute, something like this. That's what we have. There we go. Okay, that's a little bit better. All right, so read, write, execute. So basically what we have here is, if we look at like this bottom file here, we can see RWX, R, tac, WX. So you can see we got like 3 tacks here. So what does that actually mean? Basically we get something like this. We got 1, 1, 1 for that first part right there. Then we have a 1 in the R position. We have a 0 and a 0 here. We have another 0 here, and then we have a 1 and a 1. Now what does all this actually mean? Well, if we were to break this into little categories here like this, just something like that right there as best I can, what we have here is, this is the owner, permissions, owner. This is the group. And the last one, you may have guessed this, other. So anybody outside the group. So basically what this is saying, for this bottom file right here, this file number 3 here that we see, it's telling us that the owner has full read, write, executable permissions of that file. The group, everybody that's in the group can only read the file, and everybody that's outside the group can write and execute the file, which realistically you probably wouldn't do that. That's how that works. That's the basics of it. So the top one, number one, some people may see this, and if you're a system admin person, you're probably cringing as I'm saying this right here. Don't do this. You can see this is read, write, execute right here, read, write, execute. So what that's basically saying is the owner, the group, and everybody outside the group has full read, write, executable, executable control of that file. So everybody has access to it. So that's something you got to be very careful with that. And then here on the bottom, on the second one, again, the owner is read, write, execute. The group is read and executable only, and same with the other, everybody outside the group. So those are some permissions. So yeah, there we go. So just thought I'd share that with you guys. All right, so now comes the moment of truth. All right, so now let's see what happens when we, now how do we actually do our conversion? So this is where the fun part comes in. All right, so let's just start with our number 392 from yesterday. So we had 392 base 10 yesterday, and I want to continue with this number for this tutorial. Just because, so in this case, what we're going to do is we're going to convert this decimal number here, this base 10 decimal number. We're going to convert this to octal. But before we do that, and you'll remember this from the last tutorial, we have to go to binary first. So the first thing I'm going to do is I'm going to convert this to binary. So over here, this is our least significant bit side with the appropriate number of boxes today. And then this is our most significant bit side. We can see that over here. And just to get a little bit of refresher from yesterday, what we have here is this is going to be, because the binary system is base 2, we're going to start with 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, 2 to the power of 7, and then 2 to the power of 8. And then what does that give us? It's going to give us 1, 2, 4, 8, 16, 32, 64, try not to get ahead of myself, 128, and then 256. Now again, I said this in the last tutorial. Remember, every time I write this value down, I'm asking myself, can that value, can that last value, can it fit into 392? And this, so if I was to keep going over here, 512 would be the very next number, 256, if we doubled it. 512 is bigger than 392. So every number after 512, or after 256, I should say, is going to be too big. And we're just going to be zeroing it out anyway. So we can just stop at 256 at this point. So, and just like we did yesterday, I'm gonna say, can 256 go into 392? In this case, it can. So I'm gonna put a binary 1 right here, and I'm gonna subtract it from. So I'm gonna take my 392. I'm gonna subtract 256 from it. I believe that gave us. I'm still gonna check it because I don't want to guess. I did this yesterday, but 6. This is gonna be 3 and 136. So we got 136. 128 does fit into it, so we're going to put a 1 there. Subtract the 128 from that. And that's going to give us 2, 8. So we have 8 left over. And then this will be a 0, 0, 0. 8 goes into itself. So we'll subtract 8. We're left with 0. And then 4, 2, and 1, nothing can go into 0. So these all become zeros. So that's our final number. So what we end up with is 1, 1, 0, 0, 0, 1, 0, 0. And how are we going to write it? Base 2, because it's binary, just like that. All right, so now what do we do with this number? All right, so now this is what we're going to do. So the next thing we're going to do is we're gonna break this into little fields here. So what I'm going to do, I think, is I'm going to make a new. Let's see here. So I'm going to take this. So we got 1, 1, 0, 0, 1, 0, 0. So what we're going to do is we're going to make a new one of these. There we go. All right. Sorry about that, guys. All right. Sometimes technical difficulty. All right, so we got 1 1 0 0 1 0 0. So I'm gonna write that in here. So we're gonna say we got. If I can find the mouse, the computer is not cooperating here today with me. All right, let's see here. There it is. Okay, I can barely find it. Now it is late in the day, so I am tired. All right, so we got 1 1. What do we say? 0 0 1 and then 0 0. Okay, there we go. That's our binary number, right? So what do we do with this? So now how do we take this binary number to the next thing we're gonna do is we're gonna take this binary value and we're gonna convert it to octal. And this is the easy part. Super duper easy. How do we do this? We're gonna break this into 3-bit sections like so. So we're just gonna break this right down into these 3-bit little sections here. Starting at on the right and working my way left. So I'm gonna start my way. So right here we are right here. So 3 bits at a time because again, it is an octal number. 3 bits per value. And then what we're gonna do is we're gonna say this one's worth 1, 2, and 4. 1, 2, and 4. There's our scale, just like we've been doing all along. 1, 2, 4. Now, if there's not enough numbers on the most input side over here, we could just omit the last. So if there was only if it stopped right here, we could just literally just either pad this with a 0 or just omit it. So not going to affect anything. So all we do is we add these values up. So in this case, 0 plus 0 plus. So if they're all, in this case, they're all 0. So this number here is going to be 0. In this case, only the 1 bit is turned on. So that's the only value we're going to add. So that gives us a 1 in this for that value. 4 plus 2 is 6. That gives us 610. So the calculator was correct. So in this case, we end up with 610. And because it's octal, we're going to write the little base 8 below it. So just like that. So how cool is that, guys? How cool is that, right? So all right. So now what I'm going to do, I'm going to go a step further. So so we know that, so that's the basics of converting a number to octal. What else can we do with this number, though? So there's actually a really cool trick that I want to show you guys, and that is, so I'm going to rewrite this here. So we know that's our number now. Let me just clean up house here a little bit. All right, so I'm going to rewrite this up here. So we got 6, 1, and then 0. And that's our octal number. That's base 8, right? So I'm going to put the little base 8 there. So what's interesting about an octal system? So for octal numbers in an octal system, again, just like we did with base 10, in this case we have base 8. So what I'm going to do is on my rightmost position over here. Remember, these are the positions here. Each of these are the digits, and then these are the. So what I'm going to do is on the rightmost position over here, this is going to be worth 8 to the power of 0. This one's going to be worth 8 to the power of 1, and this one's going to be worth 8 to the power of 2. So that's what we get right there. So basically, this is going to be 64. So because 8 times 8 is 64. 8 times itself is 8. And then 8 times 0 is 1, just like we did before. So what we can do with this is, just like we did with base 10, if I want to get back to a decimal number, I can simply take the 64 times 6, like that right there. That's going to give me my value. Let's do that over here. So I'm going to do that over here. So 64 times 6 equals 24. So we have 36, 7, 38, 38. So 384. So that's going to give us 3, for our value, that gives us 384. Over here, we're going to do the same thing. So in this case, our position, this is worth 8. So we're going to say 8 times 8. 8 times 8. Is 64. Oh, sorry guys. I was mixing myself up there. I'm sorry about that. I made a mistake there. Sorry about that. Let me just correct that real quick. I was looking at the wrong value. So we're going to take this value here, this 8 here, and we're going to multiply by the 1 here. I was looking at the wrong value. So a little bit of, I was like, it is late today. So 8 times 1. I was wondering why my math wasn't working out. It gives us 8. And then finally we have 1 times 0, which is this value up here. 1 times 0, and that's going to give us 0. So if we add all these up, so we get, so we sum all these values together, and you can see where we're going with this. That is going to give us, so 384, it should be 392, but I'm still going to check it. So let's check this just to make sure. I don't want to make another mistake. So 384 plus 8 plus 0. I'm still going to put the 0 there just so I don't forget to add it in. So we get 12, carry the 1, that's 9, and there we get our 392 base 10. How cool is that right there? So that gives us our actual base 10 number. So that is something that I didn't know actually for a long time. So that's another way that we can actually get back to base 10. So you basically just add all your values up for the base 8 system. Make sure you're adding the right numbers though. You saw what I did there. I made my little mistake. And that will get you back to the base 10. So cool. How cool is that, right? Very, very cool. All right. So now there's one more thing I want to show you guys, and that is, let's do this. So I'm going to get rid of all this here. So let's say we want to do the division method. So we still have our division method. So this will be the, just like we did yesterday. We did this yesterday. So we're going to go a decimal number. So this is the decimal to octal method. And this is the division method for this. There we go. Okay, so just like we did yesterday, very similar. What I'm going to do is I'm going to start with the number. So in this case, 392. I'm doing this to check my work. And what are we going to do today? Well, because we're going from decimal to octal, you guessed it, maybe, if you thought of us, we're going to divide this by 8. So we're going to divide, and we're going to do just like we did yesterday. Now, a little bit more complicated than binary. With binary, if it's even, you have 0. If it's odd, you have a remainder 1. In this case, we have to actually do some long division. So in this case, I get 392. I'm going to divide this by 8 to get my remainder, which is going to be, let's see, 4, which is 32. 72. 9 times 8 is 72. Subtract the difference, that gives us 0. So what we get is 49 with a remainder of 0. I'm bringing the 49 around. 49 divided by 8. There we go. I do apologize for the mistakes tonight. It is late in the day here, and I'm super tired. I think I got like 2 hours of sleep last night, so very tired today. I don't know why I'm still awake. All right, so 6 times 8 is 48, so 6 times 8 is 48. Take the difference, that gives us 1. So here we have 6 with a remainder of 1. Just like that. And then finally we have 6 divided by 8. Zero, because 8 can't go into 6. So that's going to give us 0, 6. So we get 0 with a remainder of, look at this, 6. Now how cool is this? So then what we do, just like we did yesterday, we're going to read this from bottom to top. And that gives us our octal value, which is 610. And we're going to write that as either base 8, or as we said earlier, you could also do 0, little o, and then 610, just like that. Just like that. That's also another thing I'll bring up too here while I'm here, and that's actually why I like to cross the, just a personal preference, but you'll notice that I usually flag my 1s and tick my 0s. I do that so that I can differentiate between the O's and the 0s. For me, it just makes it a little bit easier, just in case I start going too quick. So yeah, so there we go. So again, just a little tip. Hopefully it'll help save you a little bit of headache. So that is our tutorial for tonight. So I hope you learned something. If you're new to, so again, just like I said with the last tutorial, it's all about practice. Keep practicing, practice, practice, practice. Just like when we're in school, the more homework you do, the better you're gonna get at it. And I will see you on the next one. The next tutorial is gonna be about hexadecimal. So stay tuned for the next one. And I hope you have a good night. Happy Wednesday, because it is Wednesday here. I had to get that in, guys. Those of you that know me, I'm sure you guys are laughing right now. Keep the happy Wednesday going, guys, and I'll see you tomorrow. See you on the next one. So, toodles.